Good morning all. Today we will be discussing about Diels Alder reaction. Pericyclic reactions. Pericyclic reactions goes through a concerted process and it involves the cyclic redistribution of bonding electrons. Pericyclic reactions can be divided into 5 categories: cycloaddition reaction, sigmatropic reaction, chelotropic reaction, group transfer reactions, and electrocyclic reactions. We will be discussing about cycloaddition reactions, which will involve Diels Alder reaction. So cycloaddition reactions, it results in the formation of a new ring. So it can be designated as square bracket A plus B, where A and B refers to the number of atoms that will contain the pi electrons. So cycloaddition reactions can be of 3 types: Diels Alder reactions, which is also known as 4+2 cycloaddition, monthly dipolar cycloaddition or 3+2 cycloaddition, and then 2+2 cycloaddition. Now coming towards the Diels Alder reaction, which is the topic of discussion today. Diels Alder reactions occur between a conjugated diene and an alkene. This alkene is usually known as a dienophile. So as we can see here, this 1,3-butadiene is the diene and this is the dienophile in this reaction, and this diene and dienophile upon heating will undergo Diels Alder reaction and it will result in the formation of this new cyclohexene ring. So we can see the mechanism here. The electron distribution will be taking place as shown by the arrows. So it can be in this clockwise manner or it can take place in the anti-clockwise manner, but it will result in the formation of this cyclohexene as the major product. So it was Otto Diels and his research student Kurt Alder who worked at the University of Kiel. They discovered this reaction in 1928 and for this they were awarded a Nobel Prize in 1950. Now coming to the molecular orbital picture of Diels Alder reaction, as we can see, these two orbitals will overlap with these 2 orbitals of the dienophile. These 2 orbitals of the diene will overlap with these 2 orbitals of the dienophile. As we can see, these black orbitals, they are on the same phase. They will overlap and result in the formation of a new sigma bond, and we can see these 2 green orbitals are in the same phase. They will also overlap and result in the formation of a new sigma bonds. Now we can see these 2 brown orbitals, they are also in the same phase. They can undergo a lateral overlap and it will result in the formation of a new pi bond. This is what is taking place in the Diels Alder reaction. These 2 orbitals will undergo head-on overlap. This black and this green one will undergo head-on overlap. It will result in the formation of a new sigma bond, and these 2 brown orbitals which are on the same phase, they will undergo a lateral overlap and it will result in the formation of a new pi bond. So it will result in the formation of a cyclohexane ring. So the black p orbitals are perfectly aligned to make a new sigma bond, as are the 2 green orbitals, while the 2 brown orbitals are exactly right for the new pi bond at the back of the ring. So as this is a one-step reaction, there are no intermediates. No intermediates are there in this reaction. The 2 reagents, they will undergo overlap of the orbitals and that will result in the formation of the product in a single step in a concerted manner. There is no intermediates that is present in the reaction. It will undergo through a 6-member transition state which is identical to that of the benzene. Now coming to the requirements of dienes in Diels Alder reaction. So the diene component in the Diels Alder reaction, it can be cyclic or open chain. And the cyclic dienes that are permanently in the S-cis conformation are exceptionally good at Diels Alder reaction. So the diene should be of the S-cis conformation for them to undergo the Diels Alder reaction. And if the dienes are permanently locked in the S-cis conformation, then they are extremely good for Diels Alder reaction. and the reaction rate will be higher. So cyclic dienes that are permanently in the S-trans conformation and cannot adopt the S-cis conformation will not do the Diels Alder reaction at all. If the dienes are permanently locked in the S-trans conformation, they will never undergo Diels Alder reaction because they cannot come in the S-cis conformation, which is good for Diels Alder reaction to take place. So we can see here existing in the S-trans conformation, which is the stable conformation of this 1,3-butadiene, but this S-trans conformation is not favored for the Diels Alder reaction. This S-trans conformation is favored according to the stability of this diene, but it cannot undergo Diels Alder reaction. Now this can flip. This single bond can rotate and it will flip to this S-cis conformation, but this S-cis conformation is disfavored according to the stability of the diene, but it can undergo Diels Alder reaction. So it will react with this dienophile and it will undergo Diels Alder reaction to give the cyclohexene ring. So the dienes that are permanently in the S-cis conformation and that are excellent for Diels Alder reaction, they are cyclic dienes. Some examples are the cyclopentadiene, furan, and exomethylene diene, cyclohexane 1,3 diene, etc. And dienes that are permanently in the S-trans conformation and that cannot undergo the Diels Alder reaction, they are the dienes, the cyclic locked dienes. They cannot flip and gain the S-cis conformation so as to undergo the Diels Alder reaction. Now coming to the requirements of the dienophile, they have an electron withdrawing group conjugated to the alkene. So the dienophile should have an electron withdrawing group that should be conjugated to that of the alkene. So there must be some extra conjugation. It can be either a phenyl group or a chlorine group, so that the cycloaddition reaction will occur. Otherwise, the cycloaddition reaction will not occur. Without the presence of an extra conjugation group, the cycloaddition reaction does not occur or the reaction rate will be extremely small. So we can see that the classic reaction, Diels Alder reaction that are shown in textbooks is shown here. The reaction between 1,3-butadiene and ethylene. So this can undergo Diels Alder reaction and it will result in the formation of the cyclohexene, but the reaction rate is very poor because this alkene is not substituted by any electron withdrawing group. So it can undergo a dimerization, that is one diene will act as the diene and the other diene, one of the alkene group will act as the dienophile and it will undergo Diels Alder reaction resulting in the formation of this bridged ring system. So some dienophiles for the Diels Alder reaction to occur. So these are substituted with chlorine and ester groups that are substituted with cyano group, this sulfonyl group, and here this is in conjugation with this phenyl ring, this double bond which is acting as a dienophile. It is in conjugation with this phenyl ring. So these are very good dienophiles for Diels Alder reaction to occur. Now the features of the product. These three features means that the product or the compound is a possible Diels Alder product. So the three features for identifying the product of a Diels Alder reaction are the presence of a 6-membered ring, the double bond that is present inside the ring, and a conjugating group that is present opposite to that of the double bond and which is present outside the ring. So we can see here this is a 6-membered ring and here a double bond is present inside the ring and a conjugating group, it is present outside the ring and it is opposite to that of the double bond. So these are the features that should be present for a compound to be a Diels Alder product. So the simplest way to find the starting materials is to carry out a disconnection. So how can we carry out a disconnection? So we should draw arrows accordingly that the first arrow will start from the middle of the double bond. So it will follow the same pattern as we have followed for Diels Alder reaction to occur. So we will do a reverse Diels Alder reaction. So the first arrow will start from the middle of the double bond. So it will follow this pattern, and this is a retro Diels Alder reaction. It will give the diene and the dienophile that underwent Diels Alder reaction to give the desired product. Now we will be discussing some questions, practice questions based on whatever we have discussed so far. So, which of the following dienes cannot undergo a Diels Alder reaction? Which of the following dienes cannot undergo a Diels Alder reaction? So, we have seen that the dienes should have an SS conformation for them to undergo the Diels Alder reaction. So, we can notice option D because it is a S-trans conformation. This is a S-trans conformation. So, this will not undergo Diels Alder reaction. This is permanently in SS conformation and it is good to undergo Diels Alder reaction. And here this is shown in S-trans conformation, but the presence of the single bond, it can rotate and it will come to the SS conformation. Also here it can rotate and it will come to the SS conformation and thus undergo the Diels Alder reaction. So this permanently locked S-trans conformation will not undergo Diels Alder reaction. Now coming to the second question. List the following dienes in order from most reactive to least reactive in the Diels Alder reaction. So we can see that this is permanently in the SS conformation. So it will be more reactive towards the Diels Alder reaction, and it is permanently locked in the S-trans conformation. So it is least reactive towards the Diels Alder reaction. So it will come first and it will come last. Now out of these two, these both are in SS conformation, and because of the presence of this CH3 in Wurtz ring, there can be some steric effects. Therefore, this will be more reactive than this one. So this will come 2 and this will come 3. So the order will be, this is most reactive, then comes this, then this, and finally the S-trans conformation. Now this is a previous year question from JAM 2016 question paper, which is a 2-marker question, and it is a numerical answer type question. So they have asked, among the following, the number of compounds which can participate as diene component in a Diels Alder reaction is. So they are asking, which of these following dienes can participate in the Diels Alder reaction? So this is SS conformation, it can undergo Diels Alder reaction. This is also in SS conformation, it can undergo Diels Alder reaction. This is also in SS conformation, it can undergo Diels Alder reaction. This can also undergo Diels Alder reaction as it is in SS conformation. This can also undergo Diels Alder reaction as it is in SS conformation. Here this is permanently locked in S-trans conformation, so it will not undergo Diels Alder reaction. This is also permanently locked in S-trans conformation, so it will not undergo Diels Alder reaction. This is also in SS conformation, so it will undergo Diels Alder reaction. So 1, 2, 3, 4, 5, 6. These 6 dienes can undergo or participate in the Diels Alder reaction. So the answer will be 6. I hope this is clear for everyone. If there is any doubts, you can feel free to ask in the comment section. So please like, share and subscribe for further videos. Thank you.